Okay, so in this video, we're going to take a look at maximum and minimum values. Okay, now before we even get into some of these questions, let's just think about something. Let's think about the number 846. Now, one way we could think about this number is on a number line, right? So if I wrote it on a number line, right? Okay, here's some numbers. I would have 845 there, I guess. There's my 846. There is 847. Now, supposing I knew in advance that my 846 had been rounded already, right? And I knew that it had been rounded to the nearest whole number. Well, what could this 846 have been before it had that rounding taken place? Well, we can work that out, right? Okay, we could be thinking, okay, about two particular points. Now, imagine just right in the middle there between 845 and 846. If I think about that point there, look, okay, and this space here to the right of it, well, if my number was anywhere in here, I would have been closer to 846 than to 845. So that would have been rounded in this way, and I would have had this 846. And in a similar way, if we think about this on this little mark I've made on the right here, halfway between 846 and 847, well, all the numbers in this space here, look, right? Okay, right up until that point, anything in that space would have been rounded to 846 rather than 847 because it's nearer to 846. So we've got these two values. This number here we'll discuss in a moment is the minimum value of 846, and this number here to the right is the maximum value. So what are those numbers? What is directly in the middle of 846? Well, it's going to be 845.5. Right? And the maximum value is 846.5, right in the middle. Now, some of you will be thinking to yourself, hang on a second though, if it was 846.5 exactly, well, actually, I've been told that when I have a 5 there, I'm going to be rounding up, right? So actually, it'd be 847. Now, that is true, but we're going to state this as our maximum value anyway, because what is the alternative? Well, I guess some people might be thinking, well, 846.49. Well, I would argue then, well, okay, well, what about 846.499 or 49999? You see the problem? There's no other number that's going to work. So what we do, it's our convention to say that even though if it was exactly this, we would round it up. Our maximum value of 846 is 846.5. Okay, now with that explained, please don't think this is just to do with whole numbers. What about if we had some decimals, right? So imagine 4.67 has been rounded already to 2 decimal places. What would the maximum and minimum value be then? Well, in this particular case, there's my 4.67. Let's consider that same problem, but we've got all these numbers rounded to 2 decimal places. So the next one, I guess, would be 4.68. The previous one would be 4.66. Well, in exactly the same way as the example we looked at above, we can find that minimum and maximum value of every number. The 4.67 here is going to be right in the middle of 4.66 and 4.67. That number is 4.665, with the maximum being 4.675. Okay, so we can still work out the maximum and minimum value of a number in this way. Right, so now hopefully we've understood that. Let's go and have a look at some examples, right? So for each of the lengths we've got here, state the range of values within this length must be. Okay, so let's get thinking about this. We've got 18 centimeters. Well, it appears that that has been rounded to the nearest whole centimeter, or maybe 2 significant figures. It doesn't matter, okay? The minimum is going to be 17.5 centimeters, and the maximum is going to be 18.5 centimeters. Okay, so there's our answer to part A. Let's move on to part B, 12.7 centimeters. Well, if we've got this number that's 12.7 centimeters, we would have been rounding to one decimal place, I guess, or three significant figures. Well, again, maybe I'm just going to re-emphasize this point here. We need to think about this little diagram, if you didn't know the answer to this already. And we are thinking, well, what are those two numbers, the minimum and maximum, that it would have to be, otherwise we would have had 12.6 or 12.8. Well, just like last time in the examples I've shown you, okay, my minimum value is going to be 12.65 centimeters. My maximum value is going to be 12.75 centimeters. Okay, final part of this, let's do part C. We've got 11.06 meters. So this has been rounded to two decimal places or four significant figures. Well, in the same way as the last example, the minimum is going to be 11.055 and the maximum is going to be 11.065. And we could have drawn that diagram. Interesting point to note, if you look at the first example, okay, that's got two numbers in it, and our maximum and minimum have three numbers. If we look at part B, we have 3 digits involved in our question, and our maximum and minimum have 4 digits. If we look at part C, we have 4 digits there, look, and our maximum and minimum have 5. So we've always got one extra digit there to the original value. Now, what about a more complex question? Let's take a quick look at this. So here we have a rectangle, and these two sides of the rectangle, the 4 centimeters and the 8 centimeters, well, they've been rounded to the nearest centimeter. We're not just going to find what they are this time. We're going to look in part A to find the minimum possible perimeter, and we're going to find the range of possible areas. So let's just think about that 4 centimeters. Well, the 4 centimeters could be as small as 3.5 centimeters and as big as 4.5 centimeters in reality, right? And in the same way, that 8 centimeters could be as small as 7.5 centimeters, but as big as 8.5 centimeters. So if I was thinking about that minimum possible perimeter in part A, well, that would mean that I would have the minimum sized rectangle, which would be 3.5 centimeters in width. So if I was going around the outside of the shape to find the perimeter, I would have 2 3.5s. And of course, I would also have to add the 2 lengths that are as small as possible, the 7.5 plus another 7.5. So that would be the sum that I would have to do. Well, if I add those up, I'm going to get 22 centimeters. There's my minimum possible perimeter. Okay, what about in part B then, the areas? Well, if I'm thinking about area here, okay, minimum area, well, I would need the 2 minimum values, and I multiply those together to find area. Area is length times width. So the minimum area is going to be 3.5 multiplied by 7.5. Well, that comes out at 26.25 centimeters squared. Now, my maximum area, well, that's going to be the 2 maximum values. So I'm going to need to do 4.5 multiplied by 8.5. Okay, that comes out at 38.25 centimeters. Now, maybe I could write this as an inequality statement to really represent this, okay? So my area, well, I know for a fact that it's going to be as bigger than 26.25, right? And I know that it is going to be smaller than or equal to, I guess, 38.25. Now, this is a good question, actually, about these statements. Should I change my inequality signs here? Well, I kind of should, actually, because we could actually include the 26.25 there because we would round up if it was exactly that, right? Okay, we'd be rounding, but we want to probably keep the 38.25 just as it was, as we would round up if it was exactly 8.5 and 4.5. Okay, now, final question. This is going to be a really challenging one, okay? Let's take a quick think about this. So we've got two quantities, X and Y, and they're given to one significant figure. Look, so X is 20 and Y is 40. Now, before we even get into this question about, in the different parts there, let's make sure we know the maximum and minimum values of X and Y. Now, because they have been rounded to one significant figure, well, X actually could be as low as 15, and it could be as high as 25, and Y could be as low as 35, but as high as 45. Notice my inequality sign is not, even though that maximum value is 45, my inequality sign keeps me from making sure it is exactly 45. I know that's a little confusing. Okay, so anyway, those are our maximum minimum values of X and Y. So let's think about the minimum possible value of each of these expressions. So A should be relatively straightforward. I'm going to need to use the minimum, and we're looking at minimum for every one of these answers. The minimum value of X, which is 15, plus the minimum value of Y, which is 35, right? So 15 plus 35 is 50. Okay, now let's have a think about B, right? Okay, now B's a little more tricky. We've got to do Y minus X. So what is going to make that as small as possible? Well, the original value we're starting with, Y, I guess, well, that should be quite small. That's a positive value. So let's use the 35, the smallest for Y. But if we want to try to create a small number, and we're taking something away, well, we'd want to take away as large an amount as possible to create the smallest number when we subtract it. So actually, we're going to be using the largest value of X to take it away. Okay, I mean, of course, think about it. 35 take away 25 is going to be smaller than 35 take away 15, say. Okay, so that comes out as 10. There is our minimum value. Okay, let's come and have a think about C now, the minimum value of X, Y, so timesing them together. Well, I think this is a little more straightforward because, again, we need to keep these quite small. Okay, we're going to be using the smallest value of X and the smallest value of Y, okay, to make this work. Well, if I multiply those together, I'm going to have 525. Now, further questions. Let's have a little think now about fractions. How do I make fractions as small as possible? Now, before we jump into this question, let me just show you a little thing to think about. Think about the fraction 10 divided by 2 and 10 divided by 5. Okay, well, 10 divided by 2, that one is, of course, 5, and 10 divided by 5 is, of course, 2. So what denominator made my answer smaller? Well, of course, having a larger denominator makes my answer smaller. So let's make a note of that. We are looking for a large denominator when we do this fractional division. Okay, now let's think about the numerators, right? So let's think about 20 divided by 2 and 10 divided by 2. We'll change and alter those numerators and fix the denominators. Well, 20 divided by 2 is 10. And 10 divided by 2 is 5. So if we're looking for small answers, we want to keep the denominator as small as possible. Sorry, the numerator as small as possible. So let's say we want a small numerator. Okay, so now we've had a little think about what's going to make a fraction as small as possible. Let's see if we can pick the correct answer here. So let's focus in on D. We're doing X over Y, and my previous work has told me I'm looking for the largest possible denominator. So I am thinking about Y being as large as possible. So that's going to be 45. That was my maximum there, look. And I want a small numerator as possible. So my smallest numerator I can have for X is 15. Well, 15 divided by 45 is a third, and therefore That's going to be my minimum answer. Let's focus in then now on E. Well, E is y over x. And in just the same way, I'm looking for the largest possible denominator here. Well, for x, that means 25. And then I want the smallest numerator. Well, that means my y value has to be 35. So my minimum value here, let's just simplify this. Okay, we can divide both of those by 5. It's going to be 7 over 5, which I guess we should probably write as 1 2/5. Okay, that was a tough question. This is a tough objective. I hope that was understood, and you should be able to answer